Calculate the expected value, variance and standard deviation for the probability distribution. Just use the values from earlier examples where we know that the expectation of x is 2. The variance of x was 0.5, and the standard deviation of x is the square root of 0.5, which is 0.707 to 3 decimal places. Now consider the probability distribution of y. So what we want to do is write a relationship between x and y in the form y equals ax plus b. Shouldn't have to look too long to see that y would be equal to 2x plus 3. For example, 2 times 3 is 6, add 3 gives us 9. Calculate the expected value, variance and standard deviation for y. Once again, because of the symmetry, we can see that the expectation is going to be 7. So expectation of y is equal to 7. And then we can do the necessary calculations for variance. So we've got 5 squared times 0.25. And then we'll add that to 7 squared times 0.5. Add that to 9 squared times 0.25. And take away 7 squared. And if we do that, we'll find that the variance of y is equal to 2. And that makes the standard deviation of y equal to 1.414, the square root of 2. I've given that to 3 decimal places. Write a relationship here between e of x and e of y in the form ey equals. So we know that e of x was equal to 2. 2 times 2, add 3, is equal to 7. So this one is twice the expectation of x plus 3. Note the relationship. Y is equal to 2x plus 3. Expectation of y is 2e to the x plus 3. For var x, though, remember that, for var y, var of x was equal to 0.5. 2 is just 4 times that. So it is going to be 4 times var x, which is 2 squared times var x. Variance is a squared quantity. And the 2 squared comes from here, the multiplication. This one is going to be 2 times the standard deviation of x. So what do we notice? Well, we know it was y equals 2x plus 3. And what we've noticed is that this 2 affects all of them. It affects the expectation, the variance, and the standard deviation. But the 3 only has an effect on the expectation. We've discussed this before. If this is our original distribution, and then we've moved it to here, the multiplying moves the location, but also changes the spread of the original distribution. Whereas so that's the multiplying by 2. The adding 3 will move it along, but won't change the spread. And that's why the 3 affects the expectation, but not the variance or the standard deviation.